Now what we have here is a 400mm stator and 300mm rotor. These are the various positions that this can be set in because these are only 1 inch deep. So the magnet sets are 1, 2, 3, 4, 5 magnets there and 6 magnets there. And you'll have one layer and then another layer, then another layer and another layer with only one magnet per rotor per layer. So you want these to be separated because you don't want magnetic fields to interact on one another. And this is designed so you can make it 1 meter long, 2 meters long, 5 meters long, whatever you wish. It's just a matter of stacking them. Now how it works is this magnet here pulls into that position, that then is repelled. So this is being pulled in, when it reaches here it's repelled and it will flick around 180 degrees. There's 90 degrees, there's 180. By that time the next layer will have come into position. So that's layer 1, that'll be layer 2, that'll be layer 3, that'll be layer 4, layer 5, layer 6, as many as you want. They can be as close or as far apart as you want to build it. This is how it works. Let us assume then this is a stator showing the North Pole and the South Pole. Because of the shape, and these are being held in position by a laser cut into the stator material of 1 inch thick, the magnetic field goes like so. Then this magnetic field is like so, like so, like so, like so, and then when we get to here the green dominates. So it pulls in and then pushes out. In this configuration you have the South Pole, which is giving you a configuration of gauze something like that, and it goes in this direction. So it pulls in here, that pulls in, that'll pull in to there, to there, there, and then this is quickly overcome because now you've got momentum, and as it is overcome the green is then pushed against this position here. It's all quite simple. I find by putting this one on here it's not actually necessary, but it makes it slightly more efficient. So what you have then is this area here, all green, that is all green, this is dominated by, that pulls that up because it's a North Pole, that's a South Pole, and we have then this position, so that there then becomes a larger field. But because it's further away from the stator, it's not as powerful, but it's for $2 a piece, who cares, put it in. So as I said, you have 12 layers of that configuration per individual. So that's 1 and 1 there. The next one would be 1 and 1 there. 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 Now the rotor magnets all go in a line. These, however, when it reaches the central point, changes the magnetic pole, because what I'm trying to achieve here is to get the gauze to flow along, as opposed to the problem with magnetic motors is that the gauze tends to go around. We've eliminated that by putting the fields here, 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 and then reverse it back the other way. So you've really got something like geese flying. One leading edge assists the next. When we want to disengage, we pull this out of position. So all these slide out of position. So as the unit has 12 stator rotor layers, each 25mm thick. They are spaced 25mm apart. The cost of the magnets are $2. The CAD drawings 200. They are ready with the DXF files for laser machines. Now, by using a laser machine, you can take a 4x8 sheet in America, for example, of 1-inch MDF, and it'll just cut it out within a few minutes, and you've got all your parts ready to assemble. In Australia, you might look at the MDF option, and they're 16 millimeters. So you'd put two together, you sandwich them, and make it 32 millimeters. Now the magnets have to be tailored to fit whatever material you're going to use. So you ask the laser company what they can cut, what type of material is available, and they're experts, they'll tell you what they've got and what's available. Now the best way to store power in any configuration, whether it be wind power or any form of energy, what you do is you pump water up to a tank, and then you drain it down as you require the power and feed it on the grid. So if you just have a wind generator, for example, it's much better off, much more efficient to run a gear pump and pump the water any height you want. A gear pump will go up 2 miles. So you can go any height you want, and then the fall gives you the power, putting the water back in here. So it's a sealed system. You're not waiting for a drought to break. You just use your water you got and keep on reusing it. So you can also put this kind of unit charging up batteries, or in a car you can charge up batteries and then convert the battery power that you've saved to hydrogen and run your car to assist the normal gasoline or petrol engine or diesel engine, whatever you want to use it in, and you'll have a savings of maybe 75%. No use trying to change every car on the earth. Pointless. Use the technology they've already got.